Hey everyone, and welcome to another deep dive. Today we're going to get into something that honestly kind of blows my mind, relational databases. We got this chapter from a textbook about it all, SQL programming and all that. It's just wild how much we rely on all this stuff every day without even realizing it.
It really is. And you know what gets me? How elegantly these systems are actually built. Like, yeah, you hear that digital filing cabinet analogy all the time, but there's way more to it.
Okay, so let's break that down for a second. I get the whole filing cabinet thing, tables and rows and columns, but what is it that makes a database truly, relational? They use this online store example in the book, which seems pretty relevant these days. We're all shopping online all the time.
Exactly. So think about those tables representing things like customers, orders, products. It's the connections between those tables that make it relational.
Yeah.
So each customer has a unique ID, right? And that same ID is what links them to their orders.
So it's not just about storing the data, it's about creating all these relationships between those pieces of information.
Exactly. And that's where you get into relational algebra. I know it sounds kind of intimidating, but it's really the engine behind making those connections.
Yeah.
Think of it as mathematical formulas that allow the database to solve equations based on the relationships. Show me all the products ordered by customers who live in this zip code. That kind of thing.
Yeah, that's where things get really interesting. So instead of manually digging through all this data, relational algebra lets us use those connections to pinpoint what we need.
Yeah, exactly. And that's where SQL comes in, structured query language. It's how we talk to these databases. And behind the scenes, it's using relational algebra to do its magic. And this is the part that kind of blows my mind. SQL is considered a fourth-generation language. You know why? Because you don't tell the database how to get the information. You just tell it what you want.
Wait, so it's like we've got this super smart assistant that can understand our questions and figure out how to answer them from this massive web of data.
That's a great way to think about it. And that assistant is called the query optimizer. It takes your SQL query, the what, and creates a plan, like a really efficient one, to actually get that data, like a master chess player, but for data.
That's amazing. But the book also mentions these SQL dialects. Does that mean SQL isn't actually standardized?
Well, it is, but it's got layers, right? Think about it like spoken languages. You have the standard grammar and vocabulary, but then you've got all these regional dialects that add their own flavor.
So like British English versus American English. They're both English, but with some, differences.
Exactly. You've got T-SQL from Microsoft, PL/SQL from Oracle, and others. They exist for a few reasons. History, a bit of market competition, but also each vendor might optimize their database for specific things.
So even though there's a standard, these dialects evolve to solve specific problems or cater to certain needs.
Yeah, that's a good way to put it. Don't worry, though. The core stuff in SQL is pretty much the same across the different dialects. Learn the fundamentals, you can adapt pretty easily.
Okay, that's good to know. Now, they break down SQL into different types in the textbook, DDL, DML, and DQL. They make it sound like there are different ways to interact with this data skyscraper we've built.
I like that analogy. It definitely helps to visualize the different roles that SQL can play. So first you've got DDL, data definition language. That's the architect. You're laying out the blueprint.
So DDL is all about creating the structure, tables, columns, all that.
Yep. Think about commands like create table. You're defining what kind of data can go in each column, making sure a column can't be empty or values have to be unique, things like that.
So it's like setting the roles, making sure the data has the solid foundation.
Right. Then there's DML, data manipulation language. Now you're furnishing the skyscraper, adding stuff, changing stuff, removing stuff,
So DML is like the interior designer bringing the database to life. What kind of commands are we talking about here?
Well, you've got insert to add new data, update to change existing data, and delete to get rid of data.
So that gives us control over the actual content of the database.
Yes, but where it gets really fun is DQL, data query language. This is where we put on our investigative reporter hats.
Ooh, DQL sounds like my kind of SQL. What kind of tools do we have in this category?
The big one is the select statement. It lets you ask questions like, show me all the customers who bought something last month, or what are the top selling products in each category?
Okay, now we're talking. So it's like having the power to sift through mountains of data and find exactly what we need.
That's it. And you can combine select with other clauses to do things like filter, sort, group the data. You could even join data from multiple tables. Really powerful stuff.
I can already feel the power.
Yeah.
But before we get too deep into SQL, I think it's worth backing up a bit. The book talks about these things called hierarchical and network databases, like the stuff that came before relational databases.
Yeah, those were the early days, but they had some major limitations. Imagine trying to find a book in a library where all the books are chained together in one specific order. Not very flexible.
Sounds like a nightmare.
It really was. And changing the structure of everything was a huge pain. But then along came this brilliant guy, Edgar F. Codd, and he changed everything.
He's the one who came up with the whole relational model, right? Tables, rows, columns, all that.
That's the one. His model, with its emphasis on tables and primary keys and data integrity, it laid the foundation for the modern database world.
So he's like the founding father of all this. What a legacy.
Definitely. And his work led to the development of the first prototypes, like the real early relational database systems, and that paved the way for companies like Oracle to enter the scene.
Wait, Oracle. Now that's a name everyone knows. The book actually have a whole section about Oracle and Larry Ellison. It's a wild story.
It really is. Ellison's journey, from programmer to, tech titan, it's classic Silicon Valley, but with a database twist.
And that's where we'll pick up in part 2 of our deep dive. Welcome back to the deep dive. Last time we were talking about Larry Ellison and the rise of Oracle. I gotta say, reading about this guy, it's kind of like, whoa, tech royalty, right?
Right. Yeah, Ellison's impact is huge. It's funny, it's a classic Silicon Valley story, but like the database version. He dropped out of college, had a few different jobs, and then ended up working as a programmer back in the 70s.
And that's when he first came across this whole relational database thing, right? The book mentions he read this research paper about IBM's System R project.
Yep. That paper was like a light bulb for him. He saw the potential of Codd's relational model, but he also saw a problem. IBM at the time was all about mainframe systems, those massive computers that only huge companies could afford.
So he saw a way to bring this tech to, like, the rest of us.
Exactly. He co-founded this company called Software Development Laboratories, SDL, which later became Oracle. Their goal was to create a relational database management system that could run on mini computers, which were smaller and way cheaper.
So they were taking on, like, a giant and going up against IBM.
Yeah, huge gamble.
Yeah.
But Ellison, he's a gambler. He was so convinced about relational databases. He knew if he could make it more accessible, it would change everything about how businesses handle data.
And that's what happened. Oracle's RDBMS took off, partly because it was cheaper, but also Ellison made this really smart move. He focused on portability.
Oh, that was brilliant. Their system wasn't tied to one specific hardware platform. And, back then, technology was changing so fast, that gave them a huge edge. They could sell to anyone no matter what systems they were using. IBM couldn't do that.
So they were riding the wave of all this change, and suddenly everyone had access to these relational databases.
And their timing was perfect. You had the rise of PCs, network systems. Everyone needed a way to manage all this data. Oracle was there, ready to go.
Total success story. But the book also makes this point that it wasn't just luck or good timing. Oracle kept innovating, like pushing what these databases could do.
For sure. They added things like way more powerful query optimizer, support for distributed databases, tools to manage complex transactions. All that solidified them as like the relational database company.
So Larry Ellison and Oracle, they really brought relational databases into the mainstream. It's kind of crazy to think how much our digital world is built on these ideas that Codd started.
It is, but, tech never slows down.
Right.
Even as Oracle was, top dog, new problems were popping up, data was exploding, and it wasn't all the same kind of data anymore.
Yeah, the book talks about this shift towards object-oriented programming, and that led to these object relational databases. What was the logic there?
Well, developers were having a hard time making all these object-oriented ideas fit into relational databases. They wanted a system that could handle, like, the complexity of objects, with inheritance and methods and all that, while still working with traditional data.
So object relational databases were a way to, like, combine those two worlds.
Exactly. And they worked for some stuff, but it added a lot of complexity. And often, with databases, complexity means things slow down.
And then, boom, the internet era hits. Websites, social media, e-commerce, all of a sudden there's mountains of data, and relational databases weren't really built for that.
And that's where NoSQL comes in. Not only SQL, which I kind of love. It's like, we need something different.
NoSQL databases were designed to handle like the sheer scale and variety of data that the internet was creating.
Yeah, they were built for speed, for flexibility, but often they gave up some of that strict consistency and ACD properties that relational databases have.
ASAP properties.
That's a new one.
Oh, yeah. It stands for atomicity, consistency, isolation, durability. It's this set of rules that basically guarantees that your data is accurate, that your transactions are reliable, that the database stays in a good state.
So NoSQL relaxed some of those rules to like handle all this massive data super fast.
Exactly. Think of it this way. A relational database is like a library, organized perfectly, each book in its exact spot. NoSQL is more like a giant warehouse. You can store anything fast.
Makes sense. But then the book also talks about NewSQL. That seems like another hybrid.
Yeah. NewSQL tries to get the best of both. Scalability of NoSQL, but with those ACD guarantees of relational databases. Still evolving, but definitely something to keep an eye on. The world of databases just keeps adapting.
For sure. And the biggest change lately has been the rise of cloud databases.
Mm-hmm.
Now, you don't have to manage your own hardware and all that. You can basically rent a database from Amazon or Google or Microsoft.
So it's like database power on demand.
Exactly.
Yeah.
And that's been huge for, making these powerful tools available to everybody. Startups, small businesses, even individual developers.
It's wild to think about how far we've come since those early days of, chained up books in the library, from rigid structures to these flexible systems that can handle pretty much anything. But even with all this new stuff, relational databases and SQL, it seems like those core ideas are still so important.
Absolutely. SQL is still the most popular database language out there. And if you want to work with data, it's a fundamental skill. So the next part of our deep dive, we're going to actually get into the different types of SQL statements and see how they work in the real world.
Welcome back to the deep dive. It's funny to think about. We're carrying these crazy, powerful databases around with us every day, like right in our pockets and our phones. And all of it comes down to SQL, this language that lets us talk to this whole hidden world of data.
It's true. SQL, I get it, can seem a bit intimidating at first, but it's just a way of asking questions and telling the database what to do. And like we said before, there are those three main categories, right? DDL, DML, and DQL.
Yeah. Different tools for different jobs. Let's start with that first one, DDL, Data Definition Language.
The architect, right, creates the structure.
Right. It's like, think about building a house. Before you can start putting in furniture, decorating, all that, you got to build the walls, put down the foundation, put the roof on. DDL is how we do that in the database world.
Okay, so what kind of commands would we actually use with DDL?
Well, the most basic one is create table. It's pretty straightforward. You're creating a new table, which is kind of like a room in our database house. Each table has columns, and those are like the attributes of the data, So if we're creating a table for customers, we might have columns for their name, their email, maybe their order history, all that.
Exactly. And when you define those columns, you tell it what kind of data can go in there. Text, numbers, dates, all sorts of stuff.
It's like we're making the blueprint. Everything has its place, organized logically.
Yeah. DDL also lets us set up constraints, which are kind of like the rules to make sure the data is good. So you could use not NUL to make sure our column is always filled in, like a customer's name can't be blank. Or a unique constraint to prevent duplicates, so each customer has a unique email address.
So those constraints help keep our data clean, consistent.
Definitely. And then if you need to change the structure later on, there's alter table, so you can modify existing tables, add or remove columns, change the data types, adjust those constraints, like remodeling our database house.
It's like doing renovations.
And then, if you really need to, there's drop table. Completely deletes a table. But you got to be careful with that one, like demolishing a room. Hopefully you got a backup plan.
Definitely back up your data, folks. Okay, so that's DDL. Now, DML, Data Manipulation Language. This is where we get to fill our database house up.
Yeah, DML is all about adding, changing, removing the actual data inside those tables. So your main commands here are insert, update, and delete.
All right, let's break them down. Insert, that's for adding new data, right?
Right. Like say you have a table for customer orders. Every time a new order comes in, you use insert to add a new row to that table with all the details.
Yeah.
Customer ID, what they ordered, the date, all that.
So we're bringing in the furniture, putting up the decorations, making our database house feel like home.
Love that analogy.
Yeah.
And then UPDate is like, rearranging the furniture, changing existing data. So like if a customer moves and their address changes, you use UPDate to make that change in the database.
And delete is pretty self-explanatory. Getting rid of stuff we don't need anymore. cleaning out the clutter.
Exactly. But, just like in real life, be careful with that delete button. Don't want to accidentally throw away something important.
Words to live by. Okay, so we've got the structure with DDL, we can mess with the data with DML, and now the one I'm really excited about, DQL, data query language. This is how we ask the database those questions, get those insights.
This is where it gets fun. DQL, it's all about the select statement. You're telling the database what data you want to see based on whatever criteria you need, like having a conversation with it.
So like, if I want to find all the customers who made a purchase in the last month, I can use select to set that criteria, and it'll give me exactly what I need.
Yep, and you can get super specific. There's the where clause to filter data, order by to sort it, group by Y to do calculations like sums or averages.
And remember those relational algebra things we talked about way back in part 1? Those come in here, right?
Oh, yeah. One of the coolest things about SQL is joins. It lets you combine data from multiple tables based on a column they share. So you could see not just a customer's name, but also like everything they ordered. You're joining the customer table and the orders table.
So we're piecing together different parts of our database house to see the whole picture.
Exactly. And that's where relational databases are so powerful. You can connect and analyze data from all over the place.
Yeah.
And that's how you find those hidden patterns, make smart decisions, really understand what the data is telling you.
It's mind-blowing to think that all this is happening behind the scenes every time we use our phones, go online, buy something.
And it's a testament to, how important relational databases and SQL still are. Even with all the new stuff out there, these are the foundations.
Well, I feel like we've gone on this awesome journey, like exploring the whole world of relational databases. We've seen how they work, why they matter, how they've changed over time.
But we've only scratched the surface. There's so much more to learn. All the different SQL dialects, the advanced stuff that data scientists use.
But this deep dive, I think it's given us a good foundation, right? And maybe it's even inspired some of our listeners to go out and, learn more about this whole data world.
I hope so. Because really, data, it's all about stories. And with the right tools, the right knowledge, anyone can learn to tell those stories.
That's a great way to put it. Thanks for joining us on this deep dive. And until next time, keep exploring, keep learning, keep asking questions.